Hello everyone, this is Nikhil Garg, and today we would be discussing about life cycle analysis. We would discuss what is life cycle analysis and how it is usually performed. We would discuss its individual steps in brief. So without delay, let's start. So life cycle assessment is basically an assessment of environmental impact a product has during its all life cycle. It is also sometimes called life cycle analysis, and sometimes in the short form we also use the term LCA for this particular assessment or analysis. So when we say life cycle, you can understand that we are talking about from the extraction of the raw material from the natural resources till the disposal phase. And to make the process a little bit standardized, we do have international standards available which guides us how should we perform life cycle analysis. So there is ISO 14040 and ISO 14044, which usually suggests various ways and in what ways we actually has to perform life cycle analysis. But it should be remembered that even when the process has been standardized, it is very difficult to compare to different LCAs. There are several assumptions involved in the LCA, and the goal and scope of each LCA is very different. So if we want to compare two different LCA, we have to go back and see how exactly they were computed so that we are free from some assumptions that we can easily compare these two results. No, both of them might be representing very different set of data, and it's impossible to compare them sometimes. So it's better if we want to compare two different LCA or LCA of two different products, do that yourself and compare those two LCA. That way you would be knowing that you have performed both the LCAs by having same goal in the mind and using same databases, using same assumptions, and then they would be comparable very easily. So going further, in LCA, we define inputs and outputs. That is usually the case in any kind of analysis, you know that. However, but inputs and outputs in LCA are quite different from what we usually define in finite element analysis. There we define inputs as the values we provide to the analysis, and then analysis runs and gave us some values which we terms as output. However, in LCA, technically inputs and outputs, both the values are computed by us and given to the analysis. Then why these terms are used, inputs and outputs? These terms are used with reference to the product manufacturing or product uses. So when you manufacture or use the product, you consume the raw materials, you consume energy, and you might be consuming some other natural resources such as water, air, and any other things. So that is considered as an input. But when you use or manufacture the product, I'm sorry, you do some output, you do some emissions to the environment as well, which can be air emissions, land emissions, or the water emissions. So these emissions are considered as an output. So now probably you can understand that why we define these terms as inputs and outputs. So how do we actually perform these LCA? Like how do we use these inputs and outputs to have or to measure the environmental impact? So these are the 5 stages of LCA. You may find different literature defining the LCA in different number of stages. They are basically clubbing 2 or 3 of these steps or separating one of the stage defined here in multiple stages. But ultimately we would be discussing the process or the stages of LCA in this form, in these 5 steps. So going further, the first step is goal and scope definition, which by name it's very clear that we would define the scope and we would define the goal of this LCA. Why it matters? Because depending upon the goal, our considerations of LCA would be very different. Our goal could be to have a product which is better than the previous product. So our goal is very different. Or our goal could be to make a product which serves well as per the policy or governmental guidelines in terms of environmental impact of a particular thing, then our goal is very different. Or maybe our goal is just to look into the greenhouse gas emissions of that product rather than any other kind of emissions that product might be having. So depending upon the goal, our scope is defined. That, let's say in the final example I gave, that if we just want to look at the greenhouse gases, so our scope is that only. We won't consider any other kind of outputs in our analysis. So that's why defining the goal and scope in LCA is very important. Otherwise, we would fall into an endless pit, because this is a vast field and we can keep considering whatever we want to consider and it will never end. So it is very necessary that before we start to do our process, we have to define our goals. However, except the goal and scope, we also define two other terms at this stage. One is functional unit and one is system boundary. So functional unit is the minimal unit which we consider to measure the environmental impact. Usually the unit is per unit of the product. If we are manufacturing a car, so per car, how much per car production, how much environmental impact we are having. Or sometimes if we are manufacturing a material or some other thing, we sometimes also measure per unit kilograms or per unit mass or per unit weight. So that per unit production of per unit kg of steel is better than per kg of aluminium, say. So that way also we define functional unit. But in some cases we have to be very creative. These values, that per unit kg or per unit of the product, doesn't serve well. Think about the coffee cups. We have the ceramic cups and we do have the plastic cups. If we just talk the term in terms of production of one cup, it may be possible that plastic cup may appear to be better than the ceramic ones, because it's very lightweight, it's using very less material, and probably the production cost of one cup, not the cost, we don't care about the cost in LCA, but the production outputs of the one cup might be much lesser than the clay cup. However, you yourself know that the plastic cup is not going to be beneficial for the environment. But why so? Because the plastic cup would be serving the coffee for once only. However, ceramic cup won't be having that thing. Ceramic cup can serve coffees for hundreds or thousands of times. So that way we have to define our functional unit in a way which captures this effect. So in terms of engineering, many times when we replace metallic components with composite components, the composite components are much lighter and they are much durable as well. So if we define in terms of per unit weight, which doesn't make sense, because composite components are much lighter, and if you define per kgs of material, composite materials are being penalized significantly. So we have to come up in a way, let's say if we are using that composite material in a car, so we have to define it in a way per mile run of that car, because they are durable too, so that would last much longer. So we sometimes have to come up with a very fancy or very creative functional unit as well, which captures the actual effect. Then comes the system boundaries. System boundaries basically helps us in defining the scope of the project once again. So system boundaries are stages of life cycle which we want to consider in our analysis. The most common one is cradle to grave. That is from the starting of the cradle, that is starting of the raw material acquisition to the disposal. But depending upon our goal and depending upon what we want from our analysis, we might just want to consider from cradle, that is acquisition of the material, to the factory gate. We don't want to consider the uses phase, or we don't want to consider the disposal. So that would define the cradle to gate. There can be gate to gate, from one manufacturing factory gate to the another factory gate. And when we have the materials which can be recycled or reused, then we also have a definition called cradle to cradle, that also captures that after disposal that material can be reused and remanufactured into a new material. So that's how we define the system boundary. Going to the next stage, which is life cycle inventory. Again, as the name suggests, we usually define the inventory, or we usually collect all the data in this particular stage for the inputs as well as for the outputs. So when I talk about lifecycle inventory, depending upon our system boundary, we would consider all the stages. Let's say our boundary is cradle to grave for a composite material. I keep talking about composite material because that's my background is in, that's my expertise lies in. So say we are talking about composite materials. We first have to consider the extraction of raw materials, which would then be converted into fibers and resins, and those fibers would be changed either into the form of fabric, diaphragm fabric sheets, or we might want to convert them by mixing with resin into the prepregs. So manufacturing of these components, sometimes we might even use filaments for 3D printing. Once we have these components, we want to manufacture the part, the engineering part. It could be anything. It could be the chassis of a car, it can be a hydrogen storage tank, or it can be a windmill blade, wind turbine blade. So anything we want to manufacture, that part, manufacturing of that particular part, then the use of that part, maintenance during that uses phase, and finally the disposal. Now you understand that not all of these stages would be going to get completed in one location or in one factory. So transportation comes into the picture at every stage, because there is a possibility that extraction of the raw material or the mining is happening in one location, or even in one location on the globe, like in just one country, and then that is being shifted to another country for the manufacturing of resin and manufacturing of fibers. So we have to consider the transportation as well during all of these stages. So this we discussed a little bit, like how or what kind of stages we would consider in life cycle, but what kind of data we want to consider. First, how much material are we using for our functional unit? So because we need the material, use of material, we have to know the designing of the component as well. The designing has to be completed before LCA can be performed. So we would have the material information. Then we would need the energy consumption, how much energy is being used at every stage, in what form. And then finally the outputs, the environmental impacts. So how do we usually collect this data? This is a lot of data. How do we do it? So there are several databases available in the environment, in the literature, such as CREAT, EcoInvent, ILCD, Gabi, and few more. So we usually take help of these databases to collect all of this information. But we have to be aware that these databases were developed by having a particular focus in mind at a particular location and with a particular goal. So these databases we have to use at our own discretion. We have to first understand that what data is useful for us, or what database is most aligned with our goals. Many times it may happen that not all that, like what data we want to consider for our LCA we can find in every one of them. No. And even if we can, it might mean something else in every of these database. So we have to be aware of that thing and choose which database we want to use for our analysis very properly. Let's go further. The next stage, that is impact assessment stage. It is a very interesting stage of impact of life cycle analysis. Why? You would yourself understand when we discuss about it. So the impact assessment stage starts with definition of the impact categories. So impact categories are basically the emissions to the environment, and which we define in several categories. Like it can be the category of global warming potential, it can be human toxicity, for water conditions it can be eutrophication, sometimes it could be radiation, or some ozone depletion, and various others. So these are just like, so impact categories are basically just the categories in which outputs of our LCA are categorized. you can yourself notice that these categories are not mutually exclusive. There is significant overlap between the categories. So which has to be handled while doing the impact assessment. We cannot count one emission in two different categories without performing any additional step to compensate for that effect. Also, it is not like there is an exhaustive set of lists that you have to choose impact categories among these. No, impact categories can be defined depending upon the goal and scope of your project or of your analysis. You might just want to focus on global warming, or maybe water is more concerned for you, so you may even avoid global warming. Depending upon that, you would define the impact categories for your project. So let's say we chose three different impact categories just for understanding here. One is global warming potential, one is eutrophication, and human toxicity. So now let's go to the topic, how do we do the impact assessment? What is impact assessment and how do we do it? So the first stage is in impact assessment is classification. We first have to classify all the data we have from life cycle inventory into these impact categories. So we might have data for gases, data for water emissions, data that harm the humans, and human health is suffered. So we would categorize all of this data in separate impact categories. This stage is called as classification. Once the classification is done, we would go for the characterization. One thing which I can highlight here is that, as I said previously, many times these impact categories share overlapping regions, and to accommodate that properly, we have to go for co-characterization or shared fate technique, which we won't be discussing in this video. But yeah, characterization. So what exactly the characterization is now? Now you can understand that if we consider just one category, that is global warming potential, I listed 4 gases here. But in these 4 gases, each of them has a different impact or different contribution to the global warming. Methane and carbon dioxide, equal amount of methane and carbon dioxide won't contribute equally for the global warming. So that's why to consider that effect, we have to use some factors which are scientifically calculated and convert all of this data to one scale. Usually global warming potential, it is chosen that we would express this data as carbon dioxide equivalent, but it could be any other unit or any other gas as well. So characterization basically helps us in converting, or I would say in bringing different outputs in one impact category to one single scale. So for global warming, it's carbon dioxide equivalent, but similarly we can define the one single scale or one single unit for other impact categories as well. This scale or these units are usually called as category indicators. So characterization basically defines the category indicators. The next stage is normalization. Now we can see that even when we have one value for one impact category, it is not possible to compare two different impact categories. Again, same amount of carbon dioxide equivalent and same amount of phosphate equivalent won't harm the environment in the similar way, because both of them have very different mechanism, very different impact on the environment. One is degrading the water and one is degrading the air. So we have to again come up in a way in which we can compare these values somehow. So what we do, we usually divide these category indicator values to a reference value. Reference value for individual impact category would be different. So I have written reference value for all 3 of them here, but you can consider it as reference value 1, reference value 2 and reference value 3. That is respective to individual category. So what this reference value is? So it is again up to the goal and up to the scope of the project, how do we want to define the reference value. It can be the global averages or local, your geographical location averages of that particular that particular impact to the environment. So that way we would be able to identify that for this product, we are generating this much times of the global average. So if it's too high, that means we are generating uh, too much of that particular, I won't say gas, because we are talking about category indicators here. So we are harming the environment too much, I would say, in these terms. But sometimes reference values could be the policy maker set values or the guidelines which are given that you cannot generate this particular gas more than this much amount, or things like that. Any kind of guidelines or any kind of standards which are set from the government or from any local authority, which we have to follow to perform any activity or to manufacture any product. So these can be those reference values as well. And by dividing it from the reference value, we get a dimensionless value, which is usually called as impact score of that particular category, and which can easily be compared against each other. The final stage of impact assessment is weighing. It is an optional stage. The first three stages, that is classification, characterization, and normalization, are the stages which we have to perform while we are doing the impact assessment. But weighing is an optional stage. What it does, as I keep repeating, that depending upon the goal and scope, we have to change our techniques we are using to perform an LCA. So in our goal, we might just want to focus on global warming potential, or we might belong from a location where water pollution is not a very critical aspect, because water is not being polluted or water is very fresh available over there, but air quality index is very bad, and we have to focus more on the air quality. So that way our priority are shifted. So among these impact categories, we might have one impact category which has much more priority for our particular purpose. It has nothing to do with the scientific value or anything. It has more to do with the policy objectives or the societal values. So because of these values, sometimes we assign some weights to these impact scores, and that weights are called as are considered in this weighing stage. And that's how we generate an overall environmental impact score. We can compare it against each other. We can present different graphs by adding all these scores and measuring that how our product or how our service is performing better than any other competitor of ours, or any previous product we used to produce, or whatever way we want to use our results. So that's where the result interpretation and sensitivity analysis comes into the picture. But before I go over there, there is one more step, which is the tools for impact assessment. So similar to the life cycle inventory, we have several tools available in impact assessment, which are generated or developed by keeping different focuses in the mind. So again, while using a particular tool, we have to understand that why it is used, and what it considers, which kind of life cycle assessments are it is better to use for, and which it gives the bad results for. So we have to understand all these aspects before we can pick one of the tool for our particular example. So going further, result interpretation and sensitivity analysis. So I was discussing result interpretation is basically presenting the results in a way we want to compare them, usually in the form of graphs compared against several different products. But what is sensitivity analysis? So sensitivity analysis is basically analyzing how much uncertainty is there in these results. Many times while performing the life cycle analysis, we have to make several assumptions that how our product is going to be used, or sometimes because of unavailability or proprietary reasons, we don't have any values of inputs or outputs. In that case, we have to assume those values. So we have to make sure that how much impact or how much uncertainty those assumptions impart in our final results, in our overall impact score. Depending upon that, the interpretation of our results might vary significantly. So that's why sensitivity analysis is very important to perform. And many times it also suggests us to go back and look through those assumptions we made, and sometimes to change them or sometimes to strengthen them by providing some data or some values which supports that these assumptions are close to the reality. Some other things which we should be aware of, or which we should consider, or which we might want to consider while doing LCA. So one of them is geographical location. I won't say might want to, here it is we should consider it, we has to consider it. So what happens when we change the geographical location around the world? A lot of things changes. One of them is electricity production mix changes. Different countries uses different techniques to generate electricity. Some are more dependent on fossil fuels, but some have shifted to nuclear power, which is much cleaner form of energy. So even when a product manufacturing takes so and so amount of energy, if it is being produced in India and if it is being produced in USA, the output would be very different, because the electricity production mix would be very different in two different countries. And means of transportations are different in different areas. In some cases we can easily use ships, but in some cases we have to transport the goods through aeroplanes or road travel. So that affects the how much environmental impact or how much energy we are going to consume during for that transportation, even for the same distance. Developed countries sometimes have very advanced production technologies which help them reduce this environmental impact, but which might not be available in every other country around the world. So we have to consider all these aspects. So that's why geographical location is very important while performing an LCA. So we always should use local data while we are doing the inventory analysis. Next stage is a particular example I highlighted here, which is the weight reduction in airplane. You can replace it with car as well, which I was discussing in our first, second or third, in first slide or second slide. Think about it. I'm manufacturing a car or airplane part, and because of the use of composite material, the part is much lighter now. So when the aeroplane flies, it can fly more distances. It is more efficient. It can fly more distances in the same amount of fuel. In that case, we are saving the fuel, or we are having a positive impact on the environment. But if I define my functional unit in terms of per unit of the production or per unit mile, I'm mostly considering the durability aspect, I'm considering the lightweight aspect, but I'm nowhere considering the fuel saving in the aeroplane flying itself. So sometimes it gets very tricky. How should we define the functional unit, or should we consider these fuel savings somewhere in the later stages of life cycle analysis, because that is a positive impact. So it may happen that while manufacturing of that particular product which is lighter, we might be using more energy, or we might be harming environment a little more than the traditional product, but overall we might be saving our energy significantly because we made the plane or car very efficient. So these things are much more needed to be considered in LCA to have a good result, to have a unbiased outcome in our results. The third thing is sustainability. When we talk about sustainability, there are three aspects of it. One is planet, which is basically the environmental aspect, which we discuss in LCA. But other two aspects are people, or the social aspect, and third is business aspect, or profit or prosperity. But we never discuss the social and the profit aspect of sustainability in LCA. which is not the case when it comes to the real world application. You might manufacture something which is environmentally very friendly, but if it is too costly compared to its competitive product, it is not going to sell. People won't purchase it. And no manufacturer would want to produce it on the mass scale because they won't be gaining any profit out of it. Same goes with the social aspect. Even when a product might is environmental friendly, the way it is produced require people to work in very dangerous places, in very harmful places, or it is being used by exploiting the population and using them on much lower salaries and considering them as slaves. So these kind of aspects are usually not captured in life cycle analysis. So if we want to capture those aspects, we have to look for the sustainability. So sometimes for our project, we might want to add these two more aspects to our LCA to gather better outcomes, to gather better results, or to present better results to our company. So I hope you understand a little bit about LCA now, but a last point I would like to add here, that how LCA is integrated with the designing of a product. So definitely, to perform the LCA for the first time, we need a primary design at least, because we need to know how much material is being used. But once we do that and perform our LCA, we usually ask a question: are the results of LCA satisfactory for us or satisfactory as per the guidelines we are given? If not, we usually go back to the designing phase. We change the materials we are using to environmental friendly materials, or we change the manufacturing techniques we were using to the better manufacturing technique. We try to reduce the weights and perform several changes so that we can go closer to our goal. So we change the design that require us to redo the life cycle analysis, or at least amend the life cycle analysis, and again ask the question, is the criteria satisfied now? And this is an iterative process. It keeps on going unless we are satisfied with our outcome, with our criteria, with our guidelines, and then we define that design as the final design. So that's how usually LCA is also integrated, or I would say is an essential part of designing process itself. So designing team and life cycle analysis team should work together. That's my suggestion. So that's it from my side. I hope you guys would be able to learn a lot through this video.